Hello and welcome to Zig's Math Lessons Calculus, Grade 12, Ontario Curriculum. I'd recommend you watch these videos with pencil and notebook handy, and if it's in the video, then write it down carefully in your notebook. Let's begin with a lesson on radicals. Now, the purpose of this lesson is to start sharpening up skills, and a person needs skills in factoring and times tables and fractions and radicals and things, many things. But we'll start with radicals, have to focus on something. So we'll start with rationalizing radicals. Rational number is a number that can be expressed as a fraction. That's what rational means. So irrational would mean you can't express it as a fraction. But a rational number can be expressed as a fraction with an integer numerator and an integer denominator. So 2/3, for example, is a rational number. 5 is a rational number because it's 5 over 1. Note, these would have no radicals in them. Root 3 cannot be expressed as a fraction, so it's not rational, it's irrational. Root 4, however, can be expressed as a fraction because it's 2 over 1. So the difference between rational and irrational numbers. And the title of the lesson is Rationalizing. To rationalize means to remove the radicals from expressions using algebra. First, a little bit of vocab. That's a radical. It's a root sign. What's underneath that root sign has got a name. It's called a radicand. That's an entire radical because it's entirely radicand. There's no coefficient other than 1. This is a mixed radical because it's a mix. It's got a coefficient and it's got a radicand. Example, simplify expressions involving radicals. Root 75 is root 25 root 3. Now, the thing about math facts is that they're true in both directions. I can take root 75 and break it into two parts, two factors, or I could see these two factors later in some other question and say, well, this is just root 75. So we can go back and forth across here, as is convenient for us. Also note that root 75 is root 15 times 5, but that's not helpful. This is helpful because root 25 is a number that I know. It's the number 5. So we look for perfect squares that go into the radicand. 25 is a perfect square that goes into the radicand. So it's root 25 root 3. Root 5 is that number that we know. It's 5. And so we've simplified this radical expression. Here we've already broken it. Root 48 over root 6. We could join it together. Root 48 over root 6 is root 48 over 6. So we have root 8. And so let's remember that we can divide radicands and we can multiply radicands. We've divided these radicands here. We got root 8 and root 8. Think of a perfect square that goes into root 8. Of course, it's 4 times 2 is 8, and root 4 is a number that we know. And so we've taken root 48 over root 6 and made it simpler, hence simplifying expression. Here we're going to multiply a couple of mixed radicals together, and the idea is we multiply the coefficients and we multiply the radicands, but we don't multiply coefficients times radicands. So it'll be 10 root 18. And the root 18 breaks down into two parts, one of which is a perfect square. Root 9 is actually the number 3, and so 3 times 10 is 30 root 2. And we've simplified this product of mixed radicals. D. Here we've got a mixed radical over a mixed radical, and the coefficients divide down and the radicands divide down. But the coefficients do not divide by the radicands, and vice versa. Okay, so we get 15 over 5 is 3, and 50 over 2 is 25. Root 25, of course, is a number that we know, and we have 15. And so this is the number 15 in disguise. Moving on. Root of a fraction. Well, we can break it into two parts, and root 9 is a number that we know. And the idea is we don't like to have radicals in denominators. They're not considered as simple as could be. So generally, if you're asked to simplify, generally you want to have radicals removed from denominators. So what we can do is we can multiply top and bottom by the radical that we see in the denominator. Top and bottom, multiply top and bottom by the same thing. That's like multiplying by 1. So it's going to change its appearance, but it won't change its value because we're multiplying by 1. And so multiply top times top over bottom times bottom. And root 4 is a number that we know. Note, when we multiplied bottom times bottom, we were squaring a radical. And when you square a radical, you simply remove the radical sign. So when we went root 2 times root 2, it's just 2. Remember that, because it comes in handy. Let's do this one. Now, I've seen students say, well, you're supposed to multiply top and bottom by the bottom, and they go top and bottom times 3 root 5. That works, but it's unnecessary work. You don't have to work that hard. Just multiply top and bottom by the radical. And the radical is 5, and top times top will be 5 root 10. Bottom times bottom will be 3 root 25. And 3 root 25 is 3 times the number that we know, and that's 15. And of course, now we have 5 over 15. The coefficients reduce, and we get root 10 over 3. I put these two steps in brackets because these two steps are often done in one's head. I mean, I've unraveled every single conceivable step here, but many people would look at this and say, well, this is 5, and 5 times 3 is 15, and they're down here. See, this is using this note. Remove the radical signs. 5 times 3, 15. Done. And this, of course, is 5 times root 10. But I unraveled every possible step. Here we have a compound numerator, a numerator with two terms, which can be broken into pieces. Note, you can't break a denominator into pieces this way, but you can break a numerator, because if I were to add these fractions, it would just be, I've already got a common denominator, so if I were to add these fractions, I'd be back up here. 6 over 3, of course, is 2, and root 18 breaks down into a square times root 2, because 9 times 2 is 18. Note, 6 times 3 is 18 as well, but we choose this one because root 9 is a perfect square. And root 9 is that number that we know. It's the number 3. And so the 3's cancel. Here the 3's cancel. And we get 2 plus root 2. And so this is really just this. Example, expresses an entire radical. In other words, go back the other way. Given a mixed radical, make it entire. So we have a 2 here. We want to get the 2 on the inside. We ask ourselves, well, 2 is the square root of what? It's the square root of 4. So we can go square root 4, root 3, and now multiply those together. Again, let's go again. 5 is the square root of what? It's the square root of 25. So express 5 as the square root of something. It's the square root of something, 25. And so now we can multiply those together and get root 50. Let's note, it's kind of like if the 5 wants to get inside the root sign, it has to pay the cover charge. For the 5 to get inside that root sign, the cover charge is it has to square itself. So one can just think, well, when it goes in, it's going to become 25 times 250. So this will be 49 times 5 underneath that root sign. This will be 36 times 3 underneath that root sign. And this will be the 10 will pay the cover charge and go inside the root sign, square itself, become 100 times 2. And so it's this simple, square root 200. Let's look at these. We're going to multiply a mixed radical times a bracket full of stuff. Well, this is where the distributive property comes into play, the little arrows. So we'll multiply the first terms together, so it'll be coefficients 6 root 12. And we'll multiply, and the second little arrow here will be 3 root 20. The little arrows of distributive property. And now these radicals really need to be broken down simple. So we look for perfect squares that go in. 4 times 3 is 12, 4 times 5 is 20, and root 4 is the number 2, and 6 times 2 is 12 root 3, and 3 times 2 is 6 root 5. We can go again. Squaring a binomial. Oh, squaring a binomial. We'll get 3 terms. Here's the model of squaring a binomial. We're going to square x minus y. So that will be the first term squared, double the product of the terms, and the last term squared. So it will be x squared minus 2xy plus y squared, because squares are always plus. So using this as a model, let's go up here and say, all right, we're going to square the first term and get 9 root 36. Double the product here, and the product would be minus 6, so we'll go minus 12 root 18. And then on the end, it'll be this squared with a plus sign, because squares are positive, so it'll be 4 root 9. And now root 36 is a number that we know, it's the number 6, and root 9 is a number that we know, it's 3, so 9 times 6 is 54. And 4 times 3, of course, is 12. And so the root 18 has broken down into root 9, root 2, and root 9 is 3, and 3 times 12 is this 36 here. And 54 and 12 are like terms, so they join together and make 66. Squaring a binomial. Let's look at it again. Square the first term, 9 root 36. Double the product, minus 12 root 18. And then on the end, plus 4 root 9. And then from here we have to simplify. 3 times 4 is the 12. 9 times 6 is the 54. And root 18 broke into 9 times 2 is 18. 9 is 3. And 3 times root 9 is 3. And 3 times 12 is this 36. Join these two outside terms together, we have our result. Multiplying conjugates. Conjugates. Maybe that's a new term for some. Conjugates are binomials that are identical in all ways but one. The sign in the middle. One's minus, one's plus. If they're identical in all other ways, this is 2 root 3 with a root 7. This is 2 root 3 with a root 7. One's got a plus, one's got a minus. These are called conjugates. Let's multiply these conjugates together and see what happens. To do that, we're going to need our little arrows of the distributive property. So it will have to be 4 root 9. And then the next little arrow here, it's going to be 2 root 21 with a plus. And the next little arrow here will be 2 root 21 with a minus. So it'll be minus 2 root 21. And then the last one here will be minus, because a minus times a plus is a minus, root 49. And we know that root 9 is the number 3. So this will be 3 times 4, which is 12. And we know that root 49 is the number 7. So this is minus 7. And these two terms vaporized because they offset each other. They're identical except one's plus and one's minus. So these two just offset. And 12 minus 7, of course, is 5. This is multiplying conjugates. Notice when you multiply conjugate radicals, you get a rational number. The product of conjugates is a difference of squares. Let's note, math facts are true in both directions. So you learned in grade 10 that x squared minus y squared is x minus y times x plus y, factoring a difference of squares. So you learned to go from this side to this side. And here we're making use of the fact that a product of conjugates, these are conjugates, is a subtraction of squares, a difference of squares. So we're just making use of an old fact. We're kind of making use of it backwards. When we multiply conjugates, we get a difference of squares. Let's multiply some more conjugates. These are conjugates. Let's check. They're identical, 3 root 5, 3 root 5, 4 root 2, 4 root 2, identical, except for one's got plus and one's got minus. Okay, they're conjugates. So we'll get a difference of squares then. 9 times root 25 minus 9, 16 root 4. It's a subtraction of squares. The first term squared, the last term squared. Subtraction. And of course, this is 9 times 5, and this is 16 times 2. 9 times 5 is 45, 16 times 2 is 32. Subtract them and we're done. And that's how easy it is to multiply conjugate radicals together. We recognize that we'll get a difference of squares. Rationalizing denominators. In other words, get the radical out of the denominator. Multiply top and bottom by the radical. And we've seen this before, quite recently. We're multiplying by 1, so we'll change its appearance, but not its value. That's why we're allowed to use equal signs. This becomes, let's see here, root 2 times root 2 is root 4, and we're going top times top over bottom times bottom. And root 4, of course, is the number 2, and 3 times 2 is 6. Rationalizing the denominator. Let's rationalize this denominator. Well, wait a second. This is 2 terms. If it's 2 terms, this technique won't work. We'll have to multiply top and bottom by the conjugate radical, because that always turns out to be rational. So this will be equal to itself multiplied by 1. But 1, in this case, is the conjugate radical of this over the conjugate radical of this. So notice how this here is the number 1, because 2 root 6 plus root 3 over 2 root 6 plus root 3 is the number 1. So we're going to change its appearance but not its value. On the bottom, when we go top times top over bottom times bottom, on the bottom it's going to be a subtraction of squares. Squares, it's going to be 4 times 6, because we know when we square a radical, we remove the radical. So 4 times 6. Subtract, remove the radical, 3. And on the top, 10 root 6 plus 5 root 3, and 24 minus 3, of course, is 21. And look, it's rational. Let's do it again. Top and bottom times the conjugate radical. We know we need to do this because there's 2 terms here. Top times top over bottom times bottom. Bottom times bottom is a product of conjugates, which is a difference of squares. So it's 25 times 3, 75, and 49 times 5, because you square the 7, 49, and you square the radical and remove the radical. So 49 times 5, 245. And that's negative 170. And we can multiply top and bottom by negative 1 here to get the negative out of the bottom as well. So this is going to become positive 21 root 10 minus 15 root 6 over positive 170. Another example, same idea. Multiply top and bottom by the conjugate. The conjugate being, of course, root y minus 3. And now when you multiply top times top over bottom times bottom, on the bottom we have a subtraction of squares. So it will be y minus 9. It's that simple. It's a product of conjugates, so it's a subtraction or a difference of squares. So y minus 9. This needs brackets now. And we notice we can do this. And we're left with an answer. Y minus 9 over root y plus 3 is equal to root y minus 3. Rationalize a numerator. Well, the instructions here say rationalize the numerator. So we'll have to follow the instructions. The numerator is really two terms. It's a radical plus a whole number. So we'll take that and multiply top and bottom by the conjugate. And the conjugate will be root a plus 16 minus 4. Top and bottom. These two must match because we're multiplying by 1. So when we go top times top, we'll get a difference of squares. And the square of the radical is just a plus 16. Square a radical, remove the radical. And it'll be subtraction. So it'll be minus 4 squared, which is 16. So the top becomes this, and the bottom becomes a times this in brackets. The plus 16 minus 16 vaporizes. The a's now are allowed to cancel because they are factors of numerator and denominator, leaving our result, a rational numerator. That was just a little bit of a warm-up into some math skills. I'm Ziggleby Stunk, but not really. Thanks for watching. Have a nice day. If you liked it, leave a like. If you like the content, please subscribe. And you can ask questions in the comment section, and I'll try to answer them. Have a great day.